All right, welcome to week 5, part 1, in which we're going to take a look at what are called list comprehensions, which is a fancy and simple and also complicated way of creating list objects. A comprehension is considered a Pythonic approach to building things like lists, sets, or dictionaries. And Pythonic, roughly speaking, means something that you can do in Python in a straightforward manner that it's difficult to do in other languages, or at least not in such a slick way. So you can think of Pythonic as just meaning that it's a cool way of doing things that Python can do and other languages might not be able to. Let's take a look at how we might construct a list of values. Well, one way to construct a list of values is to just define the values in the list sort of by brute force. If I say m gets square bracket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow! I didn't make any typing mistakes, which is astounding. I did have to look at my keyboard a couple times. But now I have a list that has values, integer values from 0 through 15 in it. Typing this is not a lot of fun. It is very easy to make typing mistakes. And for example, you might include 8 twice and forget to include 9. Also, if you're needing to create a really big list, then doing this manually is just not going to work. You're just not going to be able to type all that stuff out. So, in order to get more flexibility and reduce the likelihood of making various kinds of typing mistakes, you might consider starting with an empty list. Okay, so there's m. This time I'm going to start with m being an empty list, and I can use a loop with a range to append the values in the range to the list, one value at a time. That also gives me a list of values from 0 up to and including 15, that is 1 less than 16. I found that easier to type. It's a lot less likely that you're going to make typing mistakes and have duplicate values or missing values. Also, you can easily extend this loop idea to have gigantic loops. All right, I can say, well, let's say m2 starts with an empty list, and I can say for k in range 1 million, m2 dot append k. And notice how enormously fast that was. If I ask for the length of m2, it really does contain a million values. If I ask for something like m2 sub, let's say minus 10 up to and including the end of the list, here are the final 10 values in this list of a million values, and they look correct. So that's good, but it's not very cool. And it tends to make the loop look like the loop is the important thing, and when you're done with the loop, you happen to have a list. The idea of the list comprehension is you put the for loop inside of the square brackets for the list definition, and this makes it more clear that creating a list is the whole point here, and the loop is a subsidiary part of creating the list. Here is how we might create a list using a comprehension with values ranging from 0 to 15. All right, I'm going to say m gets. Now I use a square bracket because I want to create a list. And each value in the list is going to be some value k for k in the range from 0 up to but not including 16. Okay, so a comprehension always involves having a for loop that steps through the values in some iterable. In this example, the iterable is range 16. The variable k in the for loop is going to take on the values from this range, one value at a time, 0, 1, 2, up through 15. And the current value of k each time through the loop is going to be appended or is going to be added to the list. All right, so there's how I can create a list using this comprehension scheme. Now, rather than just inserting k in the list, let's suppose what I really wanted was just a list of 8 zeros. I can say, in my list, let's put in a 0 for k in range 8 in this case. So this means I want 8 zero values in my list, or I could have some arbitrary expression involving k or not involving k for k in range 8. Once again, here's a comprehension. I've got my for loop inside the comprehension, but the expression whose value is going to be added to the list to construct M3 is going to be the square of the value of k. So M3 now contains the squares of the values from 0 up through 7, okay, up to but not including 8. Generally speaking, this is what a list comprehension consists of. We use square brackets around the entire thing because we are creating a list, and then we have some expression, and it is the values of that expression that are going to become the item values in the list. Then we have a for loop that sets some variable to the sequence of values, one value at a time, from some iterable. Optionally, and we haven't seen an example of this yet, optionally, following that for loop, you could have an if decision that determines whether or not that current value of the variable is used to compute the expression. You can also, as an alternative, have another for loop. And for that matter, you can have a whole sequence of these if decisions and or for loops. Okay, now the notation here, if you're not used to programming and looking at programming documentation, may be unfamiliar, but these square brackets here in ordinary font rather than bold font, square brackets generally indicate that something is optional. Italics generally means that something is non-literal, that is, you don't literally type if underscore or underscore for, but you can type an if decision or a for loop. And finally, the ellipsis here, the 3 dots, imply that something can be repeated. So this is pretty standard notation for documentation in programming language documentation. All right. So let's take a look now at some more examples in which we're going to build up to using various of these pieces. Let me define my f to c function to be return of 5/9 times f minus 32, and we know that f to c of 212 had better be 100, f to c of 32 had better be 0. All right, in this next example of a comprehension, we're saying M4 is a list where rather than a constant like 0 or a variable like k or a simple computation involving k, this time we're going to call a function f to c of, we chose the variable name v in this case for no particular reason, and this is going to be for v in the range from 0 up to but not including 8. All right, so it's perfectly reasonable to have a function call in there which is going to compute and return some value which is then going to become part of my list. M4 is what I wanted to display. There we go. So here are the Celsius values corresponding to Fahrenheit temperatures 0, 1, 2, and so forth. Rather than using a range as my iterable, I could predefine some collection of Fahrenheit temperatures and then use that collection, probably that's a list or possibly a tuple, to drive the for loop in my comprehension. All right, so let's do this. So let's say f temps, we'll pick some interesting ones, gets, let's see, well, we know that minus 40 is where the two temperature scales cross, and we know that 32 should be 0. Curious what 0 itself is. 0, 32, 75 is a comfortable temperature, 95 is fairly hot, 212 is boiling, which ought to be 100 degrees Celsius. So let's now create a list of C temps, f to c of some value for v in these f temps. And there are the C temps corresponding to the F temps. All right, so minus 40 is in fact where they cross. Minus 40 Fahrenheit is minus 40 Celsius. 0 Fahrenheit is minus 17.777. 32 is 0. 212 is 100. 75, so apparently temperatures around 24 are comfortable in Celsius. 95 maps to 35, so temperatures up above the 30s in Celsius are going to be not very comfortable. Now, the expression that gets put into the loop can itself be some complicated thing like a collection. Here, what we're doing is creating a list of tuples where for each value in the range of integers from 0 up to but not including 8, we're going to create a tuple with that value to the 1/3 power, that value to the half power, in other words, the square root of the value, and then the value itself, the value squared, and the value cubed. Okay, so M5 is going to be a list of tuples where the elements in the tuple are v to the 1/3 power, v to the 1/2 power, v squared, and v cubed. All right, so powers of v. For, let me put my 4 on the next line down. I'm just running out of some space. And because I'm inside square brackets, it's okay with Python for me to continue typing on the next line down. For v in range 8. and here's M5. Okay, so 0 to any integer, or to any non-zero power is just going to be 0. 1 to any power is going to be 1. And then here we have 2 to the 1/3. Square root of 2 is recognizable. And then, of course, 2, 2 squared, and 2 cubed. And so on for values all the way up to 7. So 1.913 is the is 7 to the 1/3 power. 2.646 is the square root of 7, and then 7 and 49 and 343 are the value square and cube. Now, of course, we can use any kind of iterable to produce values to store in our list. Here's another form of iterable, which is a string. What we're going to get here is the one-character substrings of the string. But notice in this case that we also have an if decision tacked onto the end of our for loop. So what's happening here when we create M6 is that the characters in the list are going to be some one-character substring C for C in, this is a test, but only if the value of the current one-character substring is greater, that is, comes alphabetically later than little r. Okay, so the variable C here is going to be set, one value at a time, to the one-character substrings, T, and then H, and then I, and then S. Each of those values of C is going to be tested to see whether that value of C is greater than the string R. If the value is greater than the string R, then we're going to put that string into our list. And in fact, if we just visually look through this string, we'll see that there are not very many things in here that are greater, that is, alphabetically later than R. We have a T and an S and an S and a T and an S and a T. But H-I, space, A, E, all of those letters come before little r, so none of those are included in our list. Our list only contains the 6 one-character strings, T, S, S, T, S, T, that come lexicographically later, or that are lexicographically greater than the string little r. Okay, so that is a sequence of going from quite simple list comprehensions up to more and more complicated ones. We can have lists of constant values, lists of just the value of the variable, lists of some sort of function of the variable, lists of collections involving the variable, and in this final one we had conditional inclusion of the value depending on whether the current value of the variable was greater than r in this case, but we could compare for equality or less than or whatever else. All right, now we're going to have some practice with list comprehensions.